So these are all of the solutions to the problems on the functions worksheet. So we're starting off just evaluating a few functions. For number 1, we're given that g of t is equal to 4t minus 3. This is a linear function because t is just being raised to the first power. And all we do is substitute. So negative 1 is going to be equal to t. So we get negative 4 minus 3, which is negative 7. So g of negative 1 is equal to negative 7. And number 3, I guess I'm skipping number 2. Number 3, p of 7, we substitute in. We've got 14 plus 1, which is 15. K of 1, again just substitute. 1 squared is 1, plus 1 is equal to 2. So when we're evaluating, we're always ending up with some sort of value here. All right, let's go to the other side. We've got 2, 4, and 6. So 2k of negative 10, negative 10 squared. That's 100 plus 30 is 130. Number 4 is an absolute value function. So we get 0 minus 3, so we've got negative 3 in the absolute value, which is equal to positive 3. And the last one here, oh, this is kind of a nasty one. So we're not substituting a numeric value, we're substituting an expression, so t over 2. So we're going to take this guy over here, and instead of t, we're writing t over 2. So h of t over 2 is 2 to the negative t over 2 minus 1. And you may notice that this is not one of the answers here, and that's because they probably want us to combine these fractions. I'm going to do that on the side a little bit. So I've got negative t over 2 minus 1. In order to combine fractions, we need a common denominator. And that's going to be 2. We'll keep the signs. This is already over 2, so we'll keep the numerator as it is. But if this 1 becomes a 2, then this 1 must also be a 2. And we end up with negative t minus 2 over 2 as the exponent instead of writing this. And that looks like it is choice C. They just have these guys in a different order. All right, what's next? Number 7, find h of x squared. Okay, so same thing, we're not substituting in a value, we're substituting x squared. So here, instead of x, we're going to put x squared. So it becomes x squared plus 5. Oh, that was much nicer than number 6, which is choice B. Number 8 down here, the domain and the range of these radical functions. So if you remember, to find the domain of a radical function, we set the radicand greater than or equal to 0 because whatever is under the radical has to be 0 or positive. So we end up with x is greater than negative 4. You can write that a few different ways. There's set builder notation. This is all x's such that x is greater than or equal to negative 4. Or you can use interval notation, which goes like that. Now this is the domain. The range for our radicals, remember, goes from 0 to infinity. I think for the rest of these I'm just going to use interval notation. So here the radicand has to be greater than or equal to 0, so x has to be greater than or equal to negative 1. So the domain would be all x is bigger than negative 1. And the range, when you take a square root, the smallest value you get is 0. And then over here we've got number 9. Set that greater than or equal to 0. So the domain is all x is greater than negative 2, and the range is 0 to infinity.